Here we have a parallel circuit. Voltage source is going through our switch and our fuse to bulb C to ground, and then after our switch to bulb B to ground. So these two are in parallel together. So we're first going to measure total circuit resistance. It's isolated from my power source. I already have the switch turned on, and we get 0.7 ohms. Now we're going to measure our individual branches. So I'm going to isolate those two branches from each other and from the rest of the circuit, and we're going to measure our branches. So the first branch, bulb C, is going to be 4.9. Branch, the second branch with bulb B is going to be 1.0 ohms. So our total circuit resistance is less than either branch, thus demonstrating why we use formulas to solve for total circuit resistance in a parallel circuit. So I'm putting my circuit back together. Again, the total branch or total circuit resistance was, now it's 0.8. It was lower than that earlier. All right, so I'm going to turn this off and plug this back in, and we will start doing our total voltages and our voltage drops. Turn my meter to volts DC. I'm going to measure source voltage, 13.81. And now with the circuit on, I will measure each branch. We'll do it from. So we have 13.44 volts on bulb C, and bulb B we have 13.42. This should have some voltage drop, not much. All right, now we'll measure amperage. So we will have to take 3 different amperage readings. We're going to have to take one for the whole circuit and one for each branch. So I'm going to turn my meter to amps, move my lead over. We're going to do total circuit amperage first. So I took it from ground. I'm putting my leads right where I took it from. So the connector I pulled out and where I pulled the connector from, and we're going to turn this on. We are getting total circuit amperage as 2.312. And that's going to change as these bulbs heat up. Now I'm going to break the circuit at just branch with the C bulb. And I'm going to put my meter where I took out my leads. So this first branch is 0.256 amps. Then I swap. I'm going to put bulb C back on ground, remove bulb B's ground, and I'm going to complete the circuit using the meter. 2.08 amps for the second branch. If you add both those branches up, it should be very close to your total branch current. I didn't write any of these numbers down, so I can't show you that. So hopefully this will help you all with taking measurements and remembering how to take some of the measurements before you take your SLO test. All right, thank you.